myself, Rahul Thakkar from LJ Institutes of Engineering and Technology. In the current video lecture series, we are studying the subject of Physics Group 1. Today, we are going to start a new chapter and the name is Wave, Motion and Acoustics. It contains of about 20% syllabus of the whole Physics Group 1. So you must be compulsory doing this subject with this chapter. So what is an acoustic? In the previous video, I have defined the definition of acoustics. If you remember, let me recall it to you. Acoustic is a branch of physics that deals with the study of mechanical waves in the gases, liquids and solids, including the topics such as vibration, sound, ultrasound and infrasound. So what are mechanical waves and non-mechanical waves? So you all are aware about the types of waves such as mechanical and non-mechanical. The waves which require a material for propagation of the wave, any medium of transportation, so such a waves are known as the mechanical waves, and the waves which do not require the material for the propagation, they are known as the non-mechanical waves. So sound waves are the mechanical waves because they require some medium for the propagation. So in here, what is the medium? The medium is the air, atmosphere around surrounding us is the medium for the propagation. So the sound waves are the mechanical waves, but the light can travel in a vacuum as well. So the light waves is the non-mechanical waves. So in this video, we are going to cover the topics such as introduction to the types of waves, classification of sound waves, classification of audible sound, and characteristics of a musical sound. At the end, we will learn the difference between loudness and intensity. So, let us start with the first topic of today's session, that is types of waves. So, basically types of waves may be classified as mechanical and non-mechanical, but further they are classified as transverse waves and longitudinal waves depending on type of propagation they produce. Okay, first one was depending on medium. Now this is depending on type of propagation. Okay, so they are classified as transverse waves and longitudinal waves. So let us consider first of all transverse waves. So in transverse wave, the particle of a medium vibrate at a right angle to the direction of propagation. As you can see in the figure, the particle vibrate perpendicular to the direction of propagation. This is the direction of propagation, and the particle's movement is perpendicular to the direction of propagation. So the transverse wave consists of crust and troughs. So there is no pressure variation in this, okay, and they can propagate through solid and surface of liquids, but they cannot propagate through the gases. There is no change in the density of the medium while propagation. Light wave is an example of the transverse wave. Okay. Now next comes the longitudinal waves. So in longitudinal waves, the particle of a medium vibrate parallel to the direction of propagation. As you can see in the figure, the vibration is parallel to the direction of propagation. So longitudinal waves consist of compression and rarefaction. In transverse wave, it was crust and trough. Now over here is compression and rarefaction. Okay, there is a pressure variation throughout the medium. They can be propagated through solid, liquid and gases as well. Okay, there is a change in density throughout the medium, and sound wave is an example of longitudinal waves. Now next comes the classification of sound waves. So as we know that sound waves are of three types: infrasonic, audible and ultrasound. These three are categorized depending on the frequency. The infrasonic sound is a sound which has a frequency less than 20 Hz. Audible sound. Audible sound is a sound which can give a sensation to the human ear. This is only the sound which a human ear are capable of hearing. So audible sound has a frequency ranging from 20 Hz to 20 kilohertz or say 20,000 Hz. And whereas the ultrasound has a frequency of about greater than 20 kilohertz. So the sound which has a frequency greater than 20 kilohertz is the ultrasound. Okay. Now next topic is classification of audible sound. So audible sound can be understood as a musical sound and noise. The musical sound is a sound which creates a pleasing effect on the human ear is the musical sound, whereas a noise it produces a jarring effect on the human ear. Okay, so the audible sound can be classified in two forms, that is musical sound, that is a pleasing sound, and another one is a noise, that is a jarring sound. Okay, so let us understand the difference between these two, musical sound and the noise. So as we know that musical sound that produces a pleasing effect on the human ear, noise produces a jarring effect on the human ear. That is the first difference. Now the second difference is the waveforms are regular in shape. For the musical sound, the waveforms are regular in shape, whereas for the noise, waveforms are irregular in shape. Musical sound have definite periodicity, whereas in case of noise, it does not have definite periodicity. Musical sound do not undergo a sudden change in amplitude, whereas noise undergoes a sudden change in amplitude. So, as you can see in the figure, there is a waveform of musical sound and the noise at the end. So, musical sound has all the properties which we have listed above, and the noise shows all the properties as discussed above. Okay. So now coming to the next topic, that is the characteristics of the musical sound. So the first characteristics is the pitch. It is related to the frequency of sound. Another one is the loudness, that is related to the intensity of sound. And the third one is the timbre, that is related to the quality of the sound. So let us start with the first one, that is the pitch. It is related to the frequency of sound. Remember that point. Okay. So it is a sensation which helps in distinguishing between a note of high frequency and a low frequency sound of the same intensity. Produced by same musical instrument, the sound produced by ladies and the children is of a high pitch due to the high frequency. Greater the frequency of the sound, higher is the pitch, and vice versa. So the sound produced by the ladies and the children are of high pitch. So because of high pitch, there is a high frequency. Okay. Now loudness. So loudness is related to the intensity of sound. So it is a degree of sensation produced on ear. It varies from one listener to the another. Okay. So it is degree of sensation that is produced on human ear. So all the human beings have different characteristics. They possess different ability of listening. So likewise, different shape and different thumbprints and a different color of human being. The sensation is also different for every human being. So it varies from one person to the another person, or from one listener to the another listener. So it depends upon the intensity and sensitiveness on the ear. So that is why it is a physiological quantity. So the loudness L is proportional to the log of intensity to the base 10. On removing the proportionality, there gets some constant. So therefore, loudness is equals to K log of I to the base 10, where I is the intensity of sound. So loudness is proportional to the logarithmic function of intensity. This is known as a Weber-Frechner's law. Weber-Frechner's law. Okay. So from the above equation, on differentiating, we get dl by di is equals to k by I, where dl by di is nothing but the sensitiveness of the ear, and the sensitiveness decreases with the increase in the intensity. We can see it from the figure, from the equation. Okay, so now next topic is timbre. It is the depending on quality of the sound. So it is the quality of the sound which enables us to distinguish between two sounds having same loudness and pitch. It depends on the presence of overtones. Okay, so timbre is a characteristics of a sound that depends on the quality. Now, next topic is intensity and intensity level. So, first of all, understand intensity. So, intensity is the amount of the sound energy Q flowing per unit area in unit time when the surface is held normal to the direction of propagation of the wave. So, as you can see in the figure, or sorry, as you can see in the equation, I is equals to Q upon AT. That defines the statement. It is the amount of sound energy Q flowing per unit area in a unit time when surface is held normal to the direction of propagation of wave. Also, the another simplified form of intensity of equation is given as I is equals to 2 pi square f square a square rho v. So it is a physical quantity which depends upon the frequency, amplitude, velocity and density of the medium. Its unit is watt upon meter square. Now, next is the intensity level. The logarithmic ratio of intensity I of a sound to the standard intensity defined as the intensity level. Okay, IL, it is also known as a relative intensity. So IL is equals to K log of I to the I0. Okay, so this is the equation, but let us first of all, this is the final equation which I have told you, but let us derive that equation. Let I and I0 be the intensity of the two sounds, and L1 and L0 be the corresponding loudness. Then L1 is equals to K log of I to the base 10 and L0 is equals to K log of I0 to the base 10. So the intensity level IL is given as the difference between these two, L1 minus L0. So on substituting the values of L1 and L0, we get IL is equals to, I am repeating the final statement, IL is equals to K log of I upon I0 to the base 10 and its unit is bel, BEL. If K is equals to 1, then we can say that IL is equals to 10 log of I by I0 to the base 10. Over here I have written the unit as decibels, dB. So I have converted decibel into the bel, bel into the decibels. That is 1 bel is equals to 10 decibels. Okay. Now another two remaining definitions are standard or reference or zero intensity. That is I0. The term I0 in here is the minimum intensity which a human ear can sense is called as threshold intensity. Its value is of about 10 raised to minus 12 watt upon meter square. It is nearly about 0 decibels. So I0 is nothing but the minimum amount of intensity that a human ear can sense is known as a standard or reference or zero intensity, I0, or it is also known as a threshold intensity. Okay, now next is the threshold of feeling. The sound of intensity level 120 decibels produces a feeling of pain in the ear that is known as a threshold of feeling. Okay. Now, at the end, let us conclude the difference between the loudness and intensity. So, the loudness is the sensation produced, it is a degree of sensation produced on human ear, and intensity is the amount of sound energy per unit area in a unit time. Loudness varies from listener to listener. Intensity is independent of the listener. Since loudness varies from listener to listener, it is a physiological quantity. Since intensity is independent of the listener, it is a physical quantity. The unit of loudness is shown, unit of intensity is watt upon meter square. So that was all for this today's lecture, guys. Now in the next video, we will learn about the sound absorption and reverberation. So that's it for today, guys. Thanks for watching.